Welcome back to Coding Better Composables. In this final lesson, we'll be looking at a pattern called async without await. First, we'll look at the problem that we might run into coding components with the async await pattern. Then we'll look at the view use async state composable, and finally the use async queue composable. So let's dive right in. I think the best way to start to learn a new piece of functionality is by getting really clear on what the problem is that we need to solve. So inside our component setup function, we might see some code that looks like this. We're setting a ref, calling fetch data, which likely calls an API, returning the state, and then setting a computed property. When we call await like this inside the setup function, it returns right when it runs into that line. So at that point, it returns from the setup, the component's mounted, and the application continues executing as usual. Any reactivity defined after the await, like our computed prop here, or a watcher, or something else, won't have been initialized yet. This means a computed property defined after the await, like you see here, won't be available to the template at first. Instead, it will only exist once that async code has finished and the setup function completes execution. However, there is a way to write async components that can be used anywhere without all this trouble. And that pattern is called async without await. To use this pattern, we might write some code that looks like this. Here we're using the use async state composable, which we're going to write in a moment. Using this pattern, the async data fetch won't interfere with our reactivity, and our computer property will get run before the template is initially rendered. This pattern makes working with async code so much safer and straightforward. Anything that reduces the stuff you have to keep track of in your head is always helpful. So let's code up a composable using this pattern. First, we'll hook up all the reactive values synchronously. Then those values will be updated asynchronously once our asynchronous code finishes. So first, we'll need to get our state ready and return it. We'll initialize with a value of null because we don't know what the value is yet. Second, we'll create a method that will wait for our promise and then set the result of our state ref. Whenever this promise returns, it'll just update our state reactively. Let's add this method inside of our composable, and we'll need to run the execute function. Let's walk through this code step by step. So when it runs initially, first it's going to run the execute function. This will run this bit of code inside here and wait for the promise to finish. Then the await returns control to this point. It will return state and continue with the setup function. And sometime later, when the promise is finished, state will get updated reactively and we'll finish the method. Here's the code from the previous slide where we use async state. So now it should make a little more sense when we say that the async data fetch won't interfere with our reactivity. This is how it does it. It should come as no surprise to discover that we just coded up a simpler version of the use async state function from the view use library. It lets us execute any asynchronous method wherever we want and get the results updated reactively. Let's take a look at a slightly trimmed down version of this function from view use. You can see inside this use async state composable that we have a bunch of flags at the top that we might want to keep track of from our component. The first is, has data been fetched? With the isReady flag, is loading, which of course tracks a loading state, and then error, if we want access to any error that occurred from our composable. Here's an example of how we might code this up and get access to the isLoading ref. Feel free to pause the video if you want to read through the execute function here. I think it's pretty self-explanatory. And further down in this function, you can see we call execute and return all of our properties. Next, I want to let you know about another view use composable called use async queue. This allows you to execute each asynchronous task sequentially and pass the current task result to the next task. Here's an example of what your code might look like. A simple example here might be two API calls. So you call the first one, and maybe you need to take the results from the first one to call the second one. It would be a good use for this composable. Let me show you a simple example of how this might be used. First, we'll import this composable, and our first promise will return a new promise. It'll run set timeout, waiting 2 seconds, that's 2000 milliseconds, and it will resolve with a return value of 2. Our second promise will create a new promise, call set timeout again, waiting 2 seconds, and then resolving 3 plus the the result that we passed in from the first promise. We'll use async queue like this, passing in get first promise and get second promise. Notice here we're returning both the result and the active index, which tells us which promise is currently running. Lastly, we'll have a template, which displays our active index and our result. So to walk through this step by step, first, our get first promise will get executed. It will pause for 2 seconds, resolve and return 2. This result will get sent in to our second promise. We'll then pause for 2 seconds, and then we'll resolve and return 3 plus the result, which is 2. In the browser, here's what it might look like if we ran it. Let's look at that one more time. As you can see here, the state gets changed, as well as the data. You can see the first result, it was 2, and the second result under data here is 5. All of our processing is happening in the background thanks to the useAsyncQ function. If you want to dive into the code of the useAsyncQ function, I recommend you take a read of Michael Thiessen's original blog post that this course is based on. He walks you through the code step by step, and you can find the link in the resources for this lesson. In this lesson, we looked at the problem with the async await pattern when we use it inside of our setup function. We looked at the async without await pattern, and then defined the useAsync state function, which uses that pattern. And finally, we looked at the useAsyncQ function from the ViewUse library. The key principle is this. If we first hook up our reactive state, we can update it whenever we want, and the values will flow through the app because of reactivity. There's no need to await around. You see what I did there? Not wait around, but await around. Sorry. Anyways, I hope you enjoyed this course, and thanks for watching.